You have the international keynote speaker who has an engineering background spanning 22 years, from design to front-end to back-end to DevOps. Today he shares talks at large with developer communities worldwide. We've got the title of the talk is Let's Make a Framework. Everybody please give a warm round of applause for Tejas Kumar.
Hi. How's it going after lunch? Feeling good, satisfied, ready? We have lots of content to cover in 25 minutes, so I will speed through this. Actually, the timer isn't working, and that's great, because I can go over. Just a quick introduction. My name is Tejas. That's pronounced like contagious. And you may see me with a mask, because I may be contagious, full disclosure. But I have had the privilege of working on the teams of really great tech companies and also working in some type of consulting capacity with a number of companies over the past many, many years. And today I lead a small agency that helps developer-facing companies do DevRel, that is developer relations, well. But today we're here to talk about why everyone needs to use a framework, and we're going to do that just by building one. Okay, so we're going to do quite a deep dive, and we're going to run into the code, and you're going to learn things. How many of you use a framework here? Next.js, Remix. How many of you know how they work under the hood mechanistically? Okay, there's like 2.5. So we're going to fix that by writing some code. And this is the last slide because, again, we don't have a lot of time. So let's just get on with it. So what we have here on the left is a dog site. Anyone like dogs? Dog people? Yeah, most of you. That's great. So this is a very simple site where you can click on a chihuahua and you see the photo of a chihuahua. Great. You can click on a cavapoo. Doesn't exist. You can click on Eskimos and you can see an Eskimo, right? The problem is that this is entirely client-side rendered. And what that means is, if I view the source, this is what I'm sending to my users in terms of markup. Nothing. It's entirely rendered on the client side. So if a search engine has no support for JavaScript, you're not going to get literally anything. There is no HTML. This is not what JavaScript is for. JavaScript is supposed to progressively enhance static HTML. It's supposed to add interactivity. It's not supposed to be the entire thing. Okay? So if that's a takeaway for you, I'd encourage you to go post that on X. JavaScript is meant to enhance, not replace. Okay? Client-side rendering is problematic for that and many other reasons. So to solve this, we need to add server rendering. This is what frameworks do. Frameworks help you server render, that is, render your React components on the server side, and then stream or send text, HTML markup to a browser. Okay? That's one of the biggest value propositions of frameworks. Number two, frameworks help you with data fetching. When is the best time to fetch data in your React app? Anyone? Okay, someone said never. Actually true. But the best time to fetch data in your React app is as early as possible. This is usually outside use effect. This is usually at the server level, at the router. Okay? This is also what frameworks do. They handle data fetching and server rendering for you. So what we're going to do is we're going to implement exactly that right now, and we're going to do it with support for server components, kind of like Next.js 13. One disclaimer, this is a massive hack fest. Do not use this in production. It's just to teach you mechanistically how these things work. So with that, let's fix this by adding server rendering. Let's walk the code base first to understand what we have. What we have is, this is the client-side thing, right? So we have hydrate root from React DOM client. We render into the document the layout with a very simple router. If the location path name is /list, then show the list component. Otherwise, show the detail component. That's it. This is our client render. What is list? If we click on list, we see that we're fetching inside use effect. That's a big no-no, but it's a very common pattern. It's not a good pattern. And once we get the data, we set it in state. We set breeds. And then if we look at the JSX, we're literally, this is a one-to-one mapping where we have welcome to my dog site, welcome to my dog site. Here are some of my favorite breeds, and a list where we map. Okay? So this is the client-side application. Let's add server rendering to it. To do that, we'll have a file called server.tsx, and we'll just write a server. So we'll go import Express from Express. You can use whatever you want, by the way. I just like Express, and so I use it. We need React, of course. And we need a function from React DOM server called render to string. This is not the best way to do it. You want to probably use something asynchronous, like render to pipeable stream. But for the sake of simplicity, we're going to use this. Next, let's actually create our serverful application. So we'll call Express, and that's our app. Then we'll get on the root route, render to string this, and we'll send that. This is kind of how all server renderers work. And finally, we'll listen on port 3000. Thank you, Copilot. Great. we need to do some more work here. We need to read CSS from the file system. So to do that, we'll just tell Express that I've got some static stuff in the dist folder. And this will read CSS. Indeed, if I go look at dist, we do have some CSS here. So it's just going to read that for us. Finally, we don't really want just some random div. What we do want is layout and a component. So we'll do layout, and it requires a background color prop. We'll just say that's white. And we need to render some component on slash. But what component should we render? This is where we need serverful routing. Or in the framework world, this is called file-based routing, file system-based routing. We need to read a file from the file system based on the route and render that, okay? And this is why in Next.js you have pages as the directory or app as the directory, and then each file in there is read by the framework. This is also why in Remix you have a routes directory with all your routes in there. These opinions are because of how the frameworks work. So what you can see is we have in the pages directory 2 pages, list and detail. So what I want is when I go to /list, I render list here, and when I go to /detail, I render detail here. We can do that by turning this into a parameter. So we'll do a parameter page, which is like a variable at the router level. And now what we can do is just get the component. So const component is await. Let's make this async. And we'll await and dynamically import from the pages directory the component we need. We'll do that using Node.js's join function. And this is the current working directory. And we'll go to dist pages and then rec.params.page. That's the request parameter we just created. Finally, we'll take the default export of that. And this is our component. And by the way, this is why in Next.js, all your exports have to be default exports, because the framework needs something predictable. If it's a named export, the framework has no way of knowing what to import. So we have our component. Finally, we'll take our props from rec.query. And now we have a component to render. So we'll just render component, and we'll spread the props like that. Okay? So again, so this will give us the behavior. If I go to /list, I import, If I go to /list, I import dist pages list. If I go to /details, I import the respective file. We'll save this, and we'll run it and see if it works. So let's go here, and we'll npm run. We'll build it first, and then we'll just start the server.js. And OK, it looks good. It should be running on port 3000. Let's go to port 3000 /list. And indeed, it works. We created some server rendering. And if we look at the markup, we're actually getting some text. We're getting, we're getting RSC thingy. We're getting server time. And somewhere here it says, welcome to my dog site in the markup. Here are some of my favorite good boys. So we're actually sending more markup now from the server side. And the cool thing is this works without JavaScript. Like if I click here, not there. If I click here, it says this page doesn't appear to be using React, because all of this happens on the server side. Fantastic. However, the problem is we're not fetching any data. We're just sending HTML, and before we have the opportunity to fetch data, we're not. So we've solved a portion of the problem, right? Frameworks give you support for server rendering, as we've seen. File system-based routing, as we've seen. Let's tackle data fetching. There's multiple ways we can do this, but the way to do it in modern React is with server components. Who's using server components in production? Really? OK. He put his hand down instantly. OK. I'm using server components, but not in production. Let's implement some server component support here. So what we want to do is go to our list, and notice we're fetching some data. So in useEffect, we're doing fetch. Server components are async by default. So we'll come here and do this. And now we can do something amazing, right? We could just fetch naturally like this. We don't need any useEffect. We don't need any use state. And we can delete all of this other boilerplate stuff. Amazing, right? Our components become just so much easier to reason about. And now we have breathes, and breathes just works as expected. We can delete this thing here. So that's one component, done. It's made into a server component. Next, the detail page. Very similar. Image URL is just, we're going to await this fetch. Oh, server components, amazing. And we'll get rid of this, and we don't have set state anymore. OK. So we made 2 server components. Let's try and run this on the server renderer. So we'll kill it. We'll start it again. And what we see is TypeScript errors. So let's go fix the TypeScript errors, because React components can't be promises, is the TypeScript error. And this is true. We're going to fix it very simply by doing this. There's actually new types in React for that. So now we're listening. Let's run the website, and it crashes. Why does it crash? And that's because objects are not valid as a React child. Found object promise. And that's because these components are async. They're not functions that return JSX, they return promises. This is a problem. And this is where the secret sauce of server components happen. So at this point, some of you may be wondering, how does server components interplay with server-side rendering? Can you do SSR without RSC, that is React Server Components? Should you, can you, etc.? Let's just look at this together by implementing a server component renderer, okay? So if we go back to our server side, what we want to do is we're rendering this thing to a string, and we're sending HTML across the wire, okay? Before we render to a string, we need to go through the React tree, find async components, wait for their data, unwrap them, and then turn them into a string. We need almost a pre-compile step, okay? Let's do that. Let's create a function called unwrap RSCs. So we'll say JSX tree is, and we'll call unwrap RSC on this tree, because this tree contains server components. So unwrap RSC, and we'll do that. And then here we'll just pass in the JSX tree. Now, obviously, TypeScript's giving me trouble because this doesn't exist. So let's write it. Let's go here, and we'll say const unwrap RSC. And what we're doing is we're just taking a JSX fragment like this, and we're searching for async components, that is promises, and awaiting them. That's all we're doing. So what does that look like in code? First of all, it's an async function that needs to await things. And now we need to handle some cases. If the React node is just a string or a number or a Boolean, then we just return it as it is. Because while this is valid React stuff, this is also valid React stuff. It's just a text node. So if it's a text node, we just return a text node. We don't need to await text. So if string or number or Boolean includes type of JSX, that's our argument, then we just return it. We don't do anything. Okay? If it's an array, so if it's like, yeah, I wrote this once or twice before. If it's an array, then we just unwrap them and return them. Okay? If it's an object, this is where it gets interesting. So if type of JSX equals object, now we talk. Because all React elements, so all of these things here, they're just JavaScript objects. They're JavaScript objects with the schema of type, props, children. And type can be a string for built-in components like divs and spans, or type can be a function for function components like button, but capital B button. Okay? So we need to handle those cases. So if it's an object, we need to make sure it's not just any object, but we need to handle React elements specifically. React elements have a type of property. So what we'll do is if if JSX.typeOf, we don't need this, equals symbol.for React.element. This tells us that this is a React element, okay? And now we need to handle two types of components. Function components, like layout, or built-in components, like div and span. Okay? So we'll add another if here. Oops. So we'll add another if type of JSX.type equals string, that is if it's a built-in component, and if it's a function component. We'll handle those cases separately. And finally, an object can just be props. And props can be async also, so we need to await them. We'll handle that case later. Let's start with the string. If it's a built-in component, what we want to do is we just return the component's various properties like type and so on, but we need to unwrap the props. So props will be await unwrap RSC, unwrap RSC of JSX.props. Okay? And now if that's it, we're just returning that. So what we're doing again is we're just walking down this tree deeply, so all of these, and when we encounter something async, we're going to await it. That's all we're going to do. If it's a function component, how do we handle this case? We say const component, or rather, let's do props. Props is, and we'll await unwrap RSC of the props. And then the component, or let's say rendered, is we call JSX.type with props. And again, we just await and we unwrap. So we just keep calling unwrap RSC. And we just unwrap all the things. And finally, we return this. Actually, what's happening here is we're calling JSX.type, which is maybe an async function. Any React component is just calling a function with props. That's what we're doing here. And finally, we return that. The last thing we do is if it's just an object and that is props, then we process that as well. So what we'll do is we'll return object.entries. This is on props. In this case, JSX is props. And we'll map over that, right? And so we get the key and the value. And what we'll return is just the same key, but await unwrap RSC of value. Now this await is red. Oops. This await is red because our map function is not async. It's async now, but if you map over something async, then you need to await promise.all of the map. Okay? And finally, what we need to do is run object.fromEntries on this. This gets really long. It's fine. We can talk later. All we're doing is unwrapping props and awaiting them. So what we just built just now was a server component renderer on the server side. So what we're doing, once again, is we're taking this entire tree, finding async components, and then calling them with await. That's it. So very basic renderer. Also not good for production, but ideally this helps you understand mechanism. So we get this JSX tree of now components, but all of them have been awaited. Their data dependencies have been fulfilled. And then we further render them to a string on the server and then send them. Let's take a look and see if this works. Spoiler, it's probably not going to work, but whatever. Let's do this, and we'll reload. It failed. And this is the part where my whole thing falls apart. Objects are not valid as a React child. Am I doing something wrong? This is where my whole presentation... But I have a solution. Don't worry about it. Where? If you have the answer, you have like 30 seconds to shout it out. Otherwise, I'll spoil it for you. Await in the handler, where I have unwrap RSC. Damn it. I was going to... OK, anyway. Thank you. Nicholas. Give it up for Nicholas, everybody. It's amazing. Very good. So let's reload. Oh, look, it works. So this is... Yeah, you can applaud that if you want. This is... Thank you. This is... So this is now data fetched on the server side. And I want you to pay attention to this. We're not using React on the client side at all. So we're fetching data on the server. If we look at the markup, right, we're getting a list of dog breeds. You can see African, Airedale, Akita, Appen. These are dog breeds. And so our page now is full of markup where the data dependencies are fulfilled on the server. But this is not the full picture, because server components allow you to do a bunch of really awesome things like soft navigation on the client. And this is why. So what we're doing is we're sending an object to the client that React on the client side can pick up and render, because we're serializing the JSX tree to just JavaScript. So what we can do now is pick that up on the client side and create soft navigation. Here's an example. I enter my name, Tejas. And if I navigate, the state is blown away. You see that? That kind of sucks, especially because it's not supposed to be that way. I have like 5 minutes left, so I'm not going to write the code here, but I will check out a branch with it completed. I'll reset hard, and then I'll check out. I have a branch called spoiled. All of this, by the way, is on GitHub. I will share links after. But now if we npm run build and run the server, what you should see is the full picture list. OK, so now I enter my name, Tejas, and I click on a thing. And not only does it keep the state, but the background like smoothly transitions. How is this working? Let's walk through the code. So we render on the server side. We fetch on the server side. The second half is the client side. So what's happening? Let's take a look. In our server, we're doing something. We are taking the entire React tree, serializing it to JSON, and storing it on the window object. We can look at the code here. So we have window.initialMarkup. And you remember that function unwrap.jsx? We're just taking its output and putting it in JSON stringify. Okay? So if I go to the front page, and if I view the source, what you'll see is window.initialMarkup, and that is just a React tree of components, literally from HTML and so on. Then on the client side, what we're doing is we're hydrating root document and the markup. And the markup is coming from the server as we attach it to the window object. Okay? This is not such a big deal. Where it becomes a big deal is the next step. We are overriding, so window.addEventListener click. And on clicking on the entire window, if you click on anything that's not an anchor link, we don't do anything. If you click on an anchor link, so let's go back to that demo. If you click on one of these, we prevent default. We push state onto the history stack, and we call the function navigate. What does navigate do? Navigate does a fetch to our server that can render server components, and the server sends a JSX tree to the client, and then the client just renders that tree. We can visualize this with the network inspector here. So if I come here and open my network and go to fetch XHR, we'll preserve the log. What you can see is, as I navigate, I'll go to blue tick, and notice this fetch request. What it sent was a giant, let me make this bigger for you, a very large JSX tree with props and children and so on. And React takes this tree and renders it on the client side, leading to smooth navigation. Because React ultimately just cares about these objects with props and children. And with that, you can very easily do state persistence, smooth navigation, etc., because it's just JSX trees all the way down. It's trees from the server to the client. The client picks up the same tree, and then every time you navigate, you don't actually navigate. You just do a network request for another set of JavaScript objects, give it to React, and say, OK, now re-render with this. Right? Server components enables this. And I need to say, this is the only way so far. I think Astro is trying to do soft navigation, but can't yet. With view transitions, it can. That's a topic for another time. But this is the only way, using server components, you can do smooth navigation that persists state and re-renders effectively. Quite a bit of a deep dive. I apologize if it was too fast. Please come see me after. And now we get to go to all of the slides that I skipped in my effort to go fast. But let's come here and answer the question, does everybody need to use a framework? Frameworks enable really powerful things, from server-side rendering that give you powers with search engine optimization, to data fetching as early as possible, like at the server level, so you're not rendering, showing people something, they download JavaScript, and then fetching, you're not creating waterfalls. That's a benefit. And you can do smooth navigation and state persistence across routes. Brilliant. But again, the question, does everybody need to use a framework? And the answer is complicated. The answer is the classic engineering answer, right? The answer is that it depends. And I'm inclined to say yes. And the main reason being that if you don't use a framework, what will end up happening is you'll end up solving so many problems that at some point you'll create your own type of Frankenstein framework. And frankly, frameworks like Next.js, Remix, Gatsby, Astro, if we talk about non-React specific frameworks, all of them have thought about use cases so far and wide and have received contributions from the community that really sets you up for success in the best possible way. So let's summarize. We covered a ton of content. We covered servers. We built all of this from scratch in a couple minutes. We covered server-side rendering, data fetching, file system-based routing, server components, soft navigation, and state persistence. I hope there's been something in there that has been helpful to whet your appetite. Come see me after, and I'd love to talk to you about this all day if I could. But if you missed anything, I do have a YouTube channel that has like 3 videos. It's not really active, but this is definitely on there. And also, I'm writing a book on React that goes deep into the details. You're welcome to scan that and read it if you want to. If not, just come talk to me. That's probably more fun anyway. With that, I want to say thank you so much for having me. It's been an absolute pleasure, React Brussels.